Hello guys, I'm Tonmoy Debnath from North South University. Today I will discuss about the graph. So, what is graph? A graph is a common data structure that consists of a finite set of nodes or vertices and a set of edges connecting them. On computer screen we can see an example of a graph. So we can see the vertices are there. A, B, C, D, E are vertices in this graph, and those are connecting with each other. The connection is known as edges. So we can see a few number of edges in this graph. So that's how we can represent a graph. A graph contains V and E. V is for set of vertices and E is for set of edges. So E is a subset of V times V. What is V times V? V times V is a maximum number of edges. Suppose we have 4 vertices in a graph. So that graph has 4 vertices. So the A vertex have 4 edges, which are A to B, A to C, A to D, A to A. So each vertex has 4 edges. So the number of vertex is a 4. So we can say that the maximum number of edges of this graph will be V times V, or V square. So the number of vertices is 4. So the maximum number of edges of this graph is 4 square, or 4 times 4 equal to 16. So that's how we can calculate the maximum number of edges, or all possible combination of a graph. So we can see the other example of a graph which have few number of edges. The edges are A to B, A to C, A to D, B to C, C to C. So those are the edges of this graph, and that E is a subset of all possible combination of a graph. So the E is a subset of that. So we can easily find the maximum number of edges, or all possible combination of a graph, if we know the number of vertices. So if suppose we have 10 vertices, so how many possible combination are there, or what is the maximum number of edges in the graph? So if we have 10 vertices, the maximum number of edges will be 10 square, or 10 times 10, which is 100. So that's how we can calculate the maximum number of edges, or all possible combination of a graph. In the worst case scenario, the number of edges will be in order of V square. So yeah, that part is very important for the graph topic. Now we will discuss about the dense graph and a sparse graph. So what is dense graph? A dense graph is a graph in which the number of edges is close to the maximal number of edges. So which one is a dense graph? So the number of edges of that graph is close to the maximal number of edges, or the number of edges of the graph is almost the maximum number of edges. So we can say that it is a dense graph. On the other hand, what is sparse graph? A sparse graph is a graph with only a few edges. So that graph has few edges, we can see, or the graph's edges is close to the number of vertices is known as a sparse graph. So that graph's edges is close to the number of vertices, which is 4, and the number of edges of that graph is 5. So 5 is close to the 4, so we can call that that is a sparse graph. Now we will discuss about the graph variations. The first one is a connected graph. A connected graph has a path from every vertex to every other. We can see an example there. That graph has 3 vertices and which are connected with each other. That graph has a path from every vertex to every other. That's why it is a connected graph. The other one is an undirected graph. The undirected graph means it has no direction in the graph. We can see an example there. It has 3 vertices which are connected with each other, and the edges has no certain direction. That's why we can traverse from A to B as well as B to A, because the edges has no certain direction. A undirected graph has no self loops. Self loops are not allowed for undirected graph. The other one is directed graph. The directed graph means it has some direction between the vertices. We can see that there are 3 vertices are there, and the vertices are connected with each other, and the edges have some certain direction. For that reason we can traverse from A to B, B to B, B to C. We cannot traverse from B to A because that graph has a certain direction. And self loops are allowed for directed graph. There are more variations of graph. A weighted graph. A weighted graph associates weights with either the edges or the vertices. We can see an example there. That graph has 4 vertices: Dhaka, Khulna, Chittagong, Borishal, and the edges of that graph have some weights, which are Dhaka to Chittagong 600, Dhaka to Borishal 900, Borishal to Chittagong 600, Chittagong to Khulna 500. If we find any weights in a graph, those graphs are known as weighted graph. The next one is a multiple graph. A multiple graph allows multiple edges between the same vertices. We can see an example there. That graph has 2 vertices, Dhaka, Chittagong. The 2 vertices have 3 edges. So we can see that there are multiple edges between the same vertices. So we can call it a multiple graph because we find some multiple edges between the same vertices. Now we will discuss about the representing graphs. So how can we represent a graph by matrix and a list? Representing a graph by matrix is known as adjacency matrix, and representing a graph by list is known as adjacency list. Now we'll discuss about the adjacency matrix. Adjacency matrix represents a graph as n times n matrix. Suppose we have n vertices. In case of adjacency matrix, we have a matrix in the order of n times n. If we find edge between I and j, we will put 1 that ij position in matrix. Now we can see that we have 4 edges and n contains the number of vertices. If we find any edge between I and j, we will put 1 in ij position. If we do not find any edge in between I and j, we will put 0 in ij position of a matrix. So we can see that there is a graph which has 4 vertices. Now we're gonna represent that by a matrix which is known as adjacency matrix. So that is the matrix. Those are the vertices 1 2 3 4 1 2 3 4 and if we find any edge in the graph, we will put 1 there. If we do not find any edge in the graph, we will put 0 there. Now for start from 1 vertex. In 1 vertex we can see that it has edge between 1 to 2. We will put 1 in 1 2 position for that. So we can see that for 1 vertex we can see another edge which is 1 2 3. So we will put 1 in 1 3 position for that. So we do not find any edge between 1 to 1 1 to 4, so we will put 0 there. In vertex 2 we can see that it has an edge there which is 2 2 3, so we will put 1 in 2 3 position. So we cannot find or we don't find any edge between 2 to 1 2 to 2 2 to 4, so we will put 0 there. In vertex 3 we don't find any edge in the graph, so we will put 0 in all that position. In vertex 4 we can see that it has an edge there which is 4 2 3, so we will put 1 in 4 3 position for that. We don't find any edge between 4 to 1 4 to 2 4 to 4, so we will put 0 there. So that's how we can represent a graph by a matrix which is known as adjacency matrix. We will discuss about representing a graph by list which is known as adjacency list. So adjacency list represent a graph as a list. In adjacency list, every vertex has a list which contains the outgoing edges for that vertex. So you can see an example there of a graph which have 4 vertices there. So every vertex has a list. We can see the list here. So we're gonna represent that graph by a list which is known as adjacency list. So there are 4 lists for 4 vertices. List 1 is for 1, list 2 is for 2, list 3 is for 3, list 4 is for 4 vertex. In vertex 1 we can see there are 2 edges which are 1 to 2 1 to 3. So the outgoing edges of vertex 1 are 2 and 3. So we can see in the list 2 and 3 which are outgoing edges of 1. In vertex 2 we can see an edge between 2 and 3. 3 is the outgoing edge of 2, so we can see 3 in list 2. In vertex 3 there is no edge, so in list 3 we can see empty there. because there is no outgoing edge. In vertex 4 we can see that there is an edge between 4 to 3, so 3 is outgoing edge of 4, so we can see 3 there, because 3 is outgoing edge of 4. So that's how we can represent a graph by a list, which is known as adjacency list. It can also keep a list of edges coming into vertex. So that's my video about the graph, the variation of graphs, and the representing a graph by a matrix and a list. So thanks for watching my video, and bye for today, and take care.